Hey guys, welcome back. So this is the second video this week. There are only two, remember, because you also have your chapter test, which is only 5 questions. We're going to finish up this chapter in lesson 12, so we'll go ahead and jump right in. And I'll try to remember the keyword in this video. If you didn't check Canvas and see that I forgot the keyword in the last one, so you don't have to worry about that. There won't be a grade for it, so you're all good. That was my bad. Too tired. Okay, so multiply the two factors and simplify by adding like terms. So this is a bit of a review from the past. We have two binomials. What are we going to do to multiply them? We FOIL. So first term, so 5x times negative 3x is going to give us a negative 15x squared. Then we do outer, so 5 times 8. Or 5x times 8, I should say, is going to give us a plus 40x. Then inner, negative 7 times negative 3x will give us a positive 21x. And then negative 7 times a positive 8 will give us a negative 56. Now we combine like terms. So we're going to have negative 15x squared. 40 plus 21 is going to give us a plus 61x minus 56. So that's all you're doing for the first 3 questions, is just using FOIL and multiplying both things in the first binomial to both things in the second binomial. Okay? All right. Now for 4 through 6, guess what? We're undoing them. So we're given a quadratic expression and we want to take and factor it into the binomials. Now, remember, first thing first, when we're taking and dealing with these, we look to see if there's a greatest common factor. So is there any one number that can go into 10x squared plus 38x plus 36? Yeah, 2. So we're going to have 2 times 5x squared plus 19x plus 18. All right, now you may be noticing we have a coefficient on the x squared term, which means we can't just see what two things multiply to give us 18, add to give us 19. It's not going to work out. Instead, we have to do factor by grouping, which means we multiply the 5 and the 18 together. So 5 times 18 is going to give us 90. So now what two numbers multiply to give us 90 and add to give us 19? 10 and 9. Excellent. So we'll have 5x squared plus 10x plus 9x plus 18. Now remember, this is a step where we do the grouping. So we group the first two together, we group the second two together, and we take out what we can. So we still have this 2 on the outside. What do 5x squared and 10x have in common? 5x, excellent, so 5x. And then what's left over? Well, 5x squared divided by 5x is going to give us x, plus 10 divided by 5 is 2. Now remember, the goal is when we do factor by grouping, this parenthesis, we want to convert the 9x plus 18 into x plus 2. So what do we have to divide 9x by to make it just x? 9. So we have plus 9 and then x plus 2, because 18 divided by 9 is 2. Now, got the 2. We group what's on the outside together in a parenthesis, so 5x plus 9. Then we group and then we write what's inside the parentheses just once, x plus 2. And there's our answer. Now, you could multiply this 2 to either one of these two things, or you can leave it on the outside. Either is perfectly acceptable for a problem like this. There are different ways to take and write it as two binomials. So this is two binomials times another factor, but either will work. All right, for number 7. So on number 7, well, 7 through 9 really, we're looking at applying Cavalieri's theorem. Cavalieri's is your key word for this lesson, so check the workbook on the spelling for that, but it is Cavalieri's is your key word for this one. All right, so below are 3 quadrilaterals. Compare the perimeter and areas. How are they the same? How are they different? So, let me get this a little closer so you can see it a little better. So here on this first one, we have a parallelogram. We've got 15 and 10 for the side measures. This little bit right here is 6. Here we have a rectangle with sides of 15 and 10, and here we have a rectangle with sides of 15 and 8. Now my guess is right off the bat you're saying that the first two are the same. Now, are their areas the same, or are their perimeters the same, or are both the same? Their perimeters are the same, so 1 and 2 have same perimeters. Do they have the same areas? No, they don't. My guess is you might be saying yes, but when we find the area of a parallelogram, yes, it's base times height, but this 10 feet is not the height. That's the slanted side. Remember, height has to be a perpendicular height. So we can solve to find what this height is. We know this diagonal over here is 10, the base is 6. So Pythagorean theorem, a squared plus b squared equals c squared. So we're going to have 6 squared plus b squared equals 10 squared. So 36 plus b squared equals 100. Subtract the 36. So we have b squared equals 64. Take the square root. Can we take the square root of 64? We sure can. It gives us 8. So that means this height here is 8. Now what do you think about the perimeter and areas? Perimeter stayed the same. So the perimeter of the first two are the same. The third one has a completely different perimeter, but the first and the third have the same area. So they can look different and still have the same area, same as with perimeter, but you have to be careful. Perimeter will be the actual side lengths, whereas area, if you have a parallelogram, you have to look for the perpendicular height, not just what the side lengths are that seem to be the height, okay? All right, and the last one I'm doing with you, number 10. So you're given 2 different figures and you want to determine if each pair is similar, congruent, or neither, and then justify how you know that. So looking at this first one, we have that first cone has a radius of 1 foot, a perpendicular height of 4, and a slant height of 7. The second cone has a radius of 4, a perpendicular height of 12, and a slant height of 28. So, are these congruent? Are all the dimensions the same? Nope, so it's not congruent. What about, are they similar? Did we multiply all of them by the same amount? Well, we went from 1 foot to 4 foot, so we multiplied by 4. We went from 7 to 28, so we multiplied by 4. But we went from 4 to 12, which is only multiplying by 3. So did we multiply by the same thing every single time? Nope. So that means it's neither. Multiplied radius and slant height by 4 and perpendicular height only by 3. Which means they can't be similar and they definitely are not congruent. So remember, congruent means that all of the dimensions are going to be the exact same, so you have all the same dimensions within your figures. Similar means that you scaled them by the same amount, so you multiplied all the dimensions of one by the same number to get the other one. So if all of those would have been multiplied by 4, then it would have been similar, but in this case it wasn't. All right, if you guys have any questions, feel free to shoot me an email and I'll try to get back to you as quickly as possible. Remember, you do have the Chapter 7 test this week. Cavalieri's is your keyword for this lesson, and there is no keyword for the previous video. So for lesson 11, there is no keyword. All right, have a great week and happy mathing.